Hello and welcome to my science tutorials. In today's video, we are going to be talking about osmotic pressure of dilute solutions. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, in our first previous tutorials, we did mention that osmotic pressure is one of the colligative properties aside the vapor pressure depression, the boiling point elevation, and then the freezing point depression. Now, in today's tutorial, we want to look at what osmosis and osmotic pressure is and how we can use osmotic pressure to calculate for the molecular weight or the molecular mass of a particular solvent. Right, so we want to look at what osmosis is. So osmosis is the flow of solvent from a dilute solution to a concentrated solution through a semi-permeable membrane. So if we have two containers and they are being separated by a semi-permeable membrane, if we have the flow of what solvent from the dilute solution to the concentrated solution, we refer to that phenomenon as osmosis. Now, osmotic pressure is the external force or the external pressure applied to a solution in order to stop osmosis of the solvent into the solution through the semi-permeable membrane. So what osmotic pressure does is what it prevents osmosis from occurring, and this is an example of a colligative property, and we would like to look at what it is. So the osmotic pressure, okay, denoted by pi, okay, is the osmotic pressure denoted by pi for solutions or for dilute solutions. It's given by the Van Hoff equation as what? Pi v is equal to what? RT. Okay, so we have this as the formula for the osmotic pressure, given that what we are dealing with, what, 1 mole of the solvent. Okay, so if we have n mole of the solvent, the formula becomes what? Pi v is equal to what? nRT, where our pi, we are saying, is the osmotic pressure. Our v is what? The volume, okay, volume of solvent in liters. Okay, our T is the temperature in Kelvin. Our N is the number of moles of solute added, and then our R is a constant. Okay, and the value of this R is what? 0.0821, and the unit is what? Liters atmosphere per Kelvin per mole. Now, if you are aware that we have a formula like this in gases, which is what? PV is equal to nRT. Now, the R over here, which this is for gases, okay, the R here is what we call the gas constant, okay, and that R has a value of what? 8.314 joules per Kelvin per mole. Okay, now this R is different from the R that we are using in osmotic pressure. So when you're dealing with osmotic pressure and you're writing this formula, please do not go and use this gas constant R. Okay, so let's use this. This is what we are using. If you're not given in the question, you need to know that the value is what? 0.0821 liters atmosphere per Kelvin per mole. Okay, so that you do not get your computation wrong. All right, so with this basic introduction, let's have a look at how to use this formula for osmotic pressure to calculate for some few examples. So the first one we want to look at is a solution of sugarcane with a relative molecular mass of what? 342, containing 34.2 gram per liter, has an osmotic pressure of 2.4 atm or atmosphere at 20 degrees Celsius. We have to calculate the value of R in liters per atmosphere. So let's first of all write down our solution. And let's look at the parameters that we have. So we have a solution of sugarcane with this. So it means the molecular weight, okay, so M of sugarcane is what? 342, which is the molar mass, so it's gram per mole. And then it has this, so this is the mass concentration. So the mass concentration is given to us as 34.2 gram per liter. Now the osmotic pressure, which is pi, is given to us as what? 2.4 atm. And then the temperature is given to us as 20, which is we add 273 to it to get the absolute temperature, which is what? 293 Kelvin. All right, so if we look at the question, we can see that we have all the parameters that we need. So let's go ahead and see if we can find what the question is asking us. So we know that pi v is equal to what? nRT. Okay, so we have pi, we don't have volume, we don't have mole, we have R, we have T. So it means we need to find what? We need to find the volume, and we need to find what? The mole. All right, so because we have this, okay, the mass concentration over here is gram per liter, it is telling us that what the V, which is the volume of the solution in liters, contains what? 1 mole of the solute. So it means the volume over here, the volume of solution contains, okay, 1 mole of solute. Now if that is the case, we know that our mole from here, from this, the volume contains 1 mole of solute, we know our mole is now equal to what? 1. Okay, so we can now go ahead and use the mass concentration to look at what we can find. So we know that mass concentration is equal to what? Concentration multiplied by what? Molecular mass. All right, so from here we can make concentration the subject. If we do that, we know that we are going to get the mass concentration, which is 34.2, divided by the molar mass, which is what? 342. So it means our concentration will be what? 0.1 molar. Now that we have our concentration, okay, we need to calculate for our volume. Okay, so we know that concentration is equal to what? Mole over volume. So if we make our volume the subject, we are going to have mole over what? Concentration. And we said that the volume contains what? 1 mole of the solute. So we are using 1 as our mole. And then the concentration that we found was what? 0.1. So this is giving us our volume, okay, to be equal to what? 10 liters. 10 liters over here. Now, once we found the volume, we can now use this formula to calculate for our R. So it means our pi v, let me use another color. So our pi now is what? 2.4 multiplied by our volume is 10, which is equal to our mole, we said is 1. Our R is what we don't know, and our temperature is what? 293. All right, so it means we have this multiplied by this, we get 24 is equal to what? 293 R. So we divide both sides by 293. So we get the value of our R to be equal to what? 0.0819 what? Liters atmosphere per Kelvin per mole. So we can see that the value of the R over here that we calculated is very close to the one that I originally gave during the beginning of this tutorial, that is equal to 0.0821. So we can see the difference between this and this is what? Just plus or minus 0.0002. Okay, so this is the value of R, and we use this, okay, as standard value when we are doing calculations and we are not given R. All right, so we want to look at the second example. So example number 2, we are to calculate the osmotic pressure of 5% solution of glucose, given that the molecular weight of glucose is what, 180 at what, 18 degrees Celsius. So let's go ahead and see what we can do. So we have our solution. We have the formula, which is 5V is equal to what, nRT. You can see that we have to find osmotic pressure, so it means our pi we don't know. Our volume, let the volume be there. We know our R is equal to what, 0.0821, and then we know our temperature. We were given 18 over here, so we have 18 plus what, 273, which is equal to what, 293 Kelvin over there. Sorry, this is 291 Kelvin. All right, now we can see that we have 5% solution. So 5% solution of glucose. So it means, okay, the mass of the solute, okay, dissolved in the solution over here, 5% means what, 5 over 100. So it means the mass, okay, dissolved in a particular volume to form the solution of the glucose solution will be what, 5 grams of the glucose in what, 100 ml of the solvent to form the 5% solution. So it means our volume from this is what, 100 ml, which is equal to what, 0.1 liters. Okay, and it means from here our mass, okay, our mass M is equal to what, 5 grams. All right, so now that we have all these parameters, we can easily go ahead and calculate for our osmotic pressure. So from here we know osmotic pressure pi, the volume is what, 0.1, is equal to our N, which is the mole, is what we have over here. So our mole, we know that mole is what, mass over molar mass. So we have our mass, we said is what, 5, so we write 5 over here. Our molar mass is what, 180, so we have 180 here. Then we multiply this by our R, which we are saying is what, 0.0821. Then we multiply that by the temperature, which is what, 291 Kelvin. All right, so we have 0.1 pi is equal to, if we input everything over here into the calculator, we are going to get 0.66417. So now that we have this, we divide both sides by 0.1. So we have our pi, the value of pi, to be equal to what, 6.64 atm, or atmosphere. So that is the value of our our osmotic pressure. Right, let's have a look at one final example. So we have to calculate the osmotic pressure of a solution obtained by mixing. So we are mixing two solutions together. So 100 ml of 3.4% solution of urea, given that the molar mass of urea is 60, and 100 ml of 1.6% of solution of sugar cane, given that the molar mass is what, 342 at what, 20 degrees Celsius. Right, so let's look at what we have. The first one, the A, we have 3%, so we have 3.4% of urea. All right, so we have 3.4%. This implies our mass, okay, is 3.4 grams, and our volume is what, 100 milliliters. Okay, from over here we know our molar mass is equal to what, 60 gram per mole. This is molar mass. Okay, we know the value of our R, even if we are not given, is 0.0821 liters atmosphere per Kelvin per mole. All right, we were given temperature to be what, 20, so we add 20 to what, 273, and that will give us what, 293 Kelvin. But now remember, we have to calculate the osmotic pressure obtained by mixing. So it means we mix 100 ml of urea and then 100 ml of sugar cane. So it means the total volume for both the solution, the total volume, okay, that is V total, will be equal to 100 ml plus 100 ml, which is what, 200 ml, which is what, 0.2 liters. So it means the osmotic pressure for the first one, which is what, pi v, to become pi vt is equal to what, nRT. We know our pi, we don't know, and our volume is now 0.2. Our mole is what, the mass, which is 3.4, over the molar mass, which is 60, multiplied by the R, which is what, 0.0821, multiplied by the temperature, which is 293. So we have 0.2 pi to be equal to, if we punch everything here into the calculator, we are going to get 1.363. So our pi is equal to what, 1.363 on 0.2. So our pi is equal to what, 6.82 atm. All right, now the B. The B is also saying what, 100 ml of what, 1.6% of sugarcane solution. So 1.6 implies our mass is what, 1.6. Our volume over here is what, 100 ml, but we know which was given to us, but we know we missed two solutions. So we have the total volume, V total, is what, 200 ml, which is also equal to what, 0.2 liters. All right, we were given the molar mass to be what, 342 gram per mole, and we know we are still at the same temperature. So from here we know pi vt will be equal to what, nRT, like we have over here. So we have our pi 0.2 as the total volume. Our mole is now equal to what, the mass over the molar mass, which is 342 over here, multiplied by the R, which is 0.0821, multiplied by the temperature, which is what, 293, is what we have over here. So if we punch everything here into the calculator, we are going to get 0.1125, and if we divide it by 0.2, we are going to get our pi, which is our osmotic pressure for the B, to be what, 0.56 atm. Now remember, the main question is saying we have to calculate the osmotic pressure of the solution obtained by mixing. So since we mixed the two solutions and the individual osmotic pressures are this and this respectively, it means the total osmotic pressure, total pi, okay, is equal to what, 6.82 plus 0.56, and this is equal to what, 7.38 atm, or atmospheres. So this brings us to the end of how to calculate questions on osmotic pressure as one of the colligative properties. So thank you so much for watching, and I will see you in the next video. Bye bye.